Over the past few decades, global warming and climate change have quickly risen in their popularity as two of the most controversial contemporary subjects. They have impacted both the political and environmental spectrums, creating many movements and research projects to identify what it actually is. Scientists are racing against the clock to answer hundreds of questions that lay before us. Even as they find an answer to one question, several more replace it. With so many questions to answer, it is important that we are first able to identify and answer the most basic questions. So what is global warming? To find out, let's talk to a notable climatologist, Professor Kira T. Lawrence at Lafayette College.
Global warming has a particular connection to anthropogenic, meaning human-induced climate change, whereas the term climate change is used as in association with anthropogenic climate change, but also is used more broadly to represent also events that have happened in the paleo or the past record of climate.
In the past few centuries, humans have significantly influenced the Earth's rising temperatures. Studies show that the Earth has historically gone through a cyclic process of global cooling and warming that occurs over several thousands of years. However, in the past few hundred years, temperatures have risen far above any past recorded temperatures. Another critical piece of information that proves the human race's involvement in global warming is found in important data. This data shows that the Earth, in fact, should be headed towards a period of global cooling rather than warming. Obviously, the Earth is experiencing a completely new trend in temperatures. Thus, scientists are very inclined to believe that modern climate change is heavily influenced by humans.
Events that we're experiencing in the modern are a consequence of us altering one of the important, what I would call, knobs in the climate system that can change the climate that we experience on Earth. So, is human-induced climate change happening? Yes. Are we a significant player in that process? Absolutely.
Professor Lawrence speaks of knobs that can be turned to change global temperatures. Among the other knobs that alter temperatures are methane and carbon dioxide. These two gases, along with water vapor, are known as greenhouse gases. These greenhouse gases are huge players in global warming due to their molecular structure.
Climate change is based upon some pretty simple physics and chemistry. So carbon dioxide and methane, which are the primary greenhouse gases that are in our atmosphere, they represent only trace amounts of chemicals in the atmosphere, but they are enormously important in terms of their heat trapping capabilities. And we very clearly are altering the composition, how much of them are present in the atmosphere. And we know that these molecules are extraordinarily effective at trapping heat or infrared energy of a particular wavelength. And so, even from a very simple chemistry and physics perspective, the fact that we're putting these chemicals in the atmosphere and that the Earth is emitting infrared energy should tell us that the Earth should be warming up. Beyond that, we can demonstrate from observations of the climate system in the modern and fairly recent relative to observations of the climate system from the geologic record that we are headed in a direction of warmth and we actually should be headed towards a colder time.
This chart plots atmospheric concentrations of carbon dioxide over several thousand years. On the y-axis is the concentration of carbon dioxide in the atmosphere. Currently, according to Professor Lawrence, the Earth is at levels of 400 parts per million of carbon dioxide, which is nearly double the levels it was at just 200 years ago. This is quite alarming because each wave of the cycle that the Earth has followed for millions of years show a low point of about 200 parts per million and a high point of about 300 parts per million. For the first time in the recorded 800,000 years on this chart, the Earth has broken its own cycle. Clearly, based on the cyclic data, the atmospheric concentrations of carbon dioxide should, in fact, be decreasing. However, the data clearly contradicts this information. Although climate change has happened since the Earth's birth, and will continue to happen until the Earth dies, it seems as if humans are drastically impacting the amount of carbon dioxide emissions. These emissions are an important part of global warming due to their heat-trapping capabilities, as explained by Professor Lawrence. This chart shows the total human population graphed with total carbon emissions on Earth. This data suggests that humans are responsible for a large portion of modern global warming.
There are basically three ways to change the temperature of a planet. You can change the amount or distribution of solar radiation. So that means either turn the sun up or down. The sun has been getting brighter over time. You can change how the Earth is positioned in its orbit relative to the sun, and that changes the distribution of radiation, and that can have climate consequences. So if you orient the Earth such that the axis of rotation is pointed more towards the sun, then it's harder for ice sheets to stick around, for instance. If you change the tilt of the Earth such that the axis of rotation is not pointed directly at the sun, then it's easier to keep ice sheets around. So you can change the climate in that way. You can change what's called albedo, which is the reflectivity of Earth's surfaces. The easiest example of albedo is something called the ice albedo feedback. So snow and ice are highly reflective. So energy that would be entering the climate system, instead of entering and being absorbed, if it is incident or directed at a highly reflective surface, then it just gets reflected right back out to space and plays no role in the climate system. So if you make the Earth have more reflective surfaces, and the easiest way to think about this is make bigger ice sheets, then the amount of energy entering into the climate system is less. You can think really what we're talking about when we talk about climate change is we're talking about a budget, a radiation budget. So there are basically three knobs you can turn. The amount of solar radiation, the reflectivity of Earth's surfaces, making that bigger or smaller, and the concentration of greenhouse gases in the atmosphere.
Alarmingly, many polar ice caps are melting quickly. A significant reduction in the amount of sea ice means that it will have become liquid water. These ice caps, when melted, will add dozens of feet of water to the ocean, drowning hundreds of prominent cities underwater, including Miami and New York City.
What is worrisome to the climate community, myself included, is that the concentration of greenhouse gases in the atmosphere where we are right now, and at higher levels, we are really confident that much of the Greenland ice sheet and part of the West Antarctic ice sheet are unstable. So Greenland holds in the ballpark of 6 to 7 meters of sea level, and West Antarctica is in the ballpark of 5 to 6 meters of sea level. Again, multiply by about 3.3 and you end up with how many feet that is. That's a lot of sea level we're talking about.
From all this information, it is clear that humans must do something about our situation with the Earth's rampant increasing global temperatures. Humans from all across the world must come together and choose to either mitigate and reduce global warming, or adapt to the changing global temperatures. Attempts to mitigate the situation have already been made. For example, the Montreal and Kyoto Protocols of 1987 and 1997, respectively, attempted to limit the use of chlorofluorocarbons, as well as other causes of anthropogenic global warming.
Mitigation, which means trying to curtail human anthropogenic, anthro means people, right, genic generated effect on the climate system, will be important if we don't want to see a big magnitude of climate change. So if you're concerned about a number of things that human societies worry about, mitigating, meaning curtailing greenhouse gas emissions, should be a very primary goal of human societies. This is not a very easily tractable problem. It's enormously complicated. We're talking about nation states. Substances that are used as the primary source of energy that drives human society, right? So this is a very, very tricky problem, which means that mitigation is not something that's very easy to do because there's so many different interests involved. So adaptation is something that can be dealt with on a more regional scale, and should be, in fact, dealt with on a more regional scale because the impacts of climate change for each region will be somewhat different and will differ based upon the resources that are available to that particular society or part of group collection of people to deal with what's facing them, right? So, if you're in some place that's going to be moving towards more drought, there are other places going to be moving towards more rainfall. So, each different region will have a different adaptation perspective or scenario that they need to think about. I think it is wise, given that mitigating the problem, while essential, and I think something that society really needs to undertake, is so seemingly intractable right now, that it would be wise for people to think about adaptation with the particular set of climate impacts that will influence their region most significantly.
Apart from mitigation and stopping of global warming, adaptation is our only other choice. Humans must adapt to global warming in order to survive, using various technological innovations. For example, we must learn to move inland, similar to how the iconic polar bear has been moving inland as its habitat on the polar ice caps melt. One of the greatest technological innovations to deal with the diverse effects of global warming is the Thames River Barrier. Built in 1982, this barrier protects over 1 million London citizens from rising sea levels, tides, and storm surges. Technological advances like this are crucial to adapting to global warming and climate change.
There are a lot of technical innovations out there that could get us to helping curtail human emissions. And I think there are some, in my opinion, there are some creative things that are coming online to help people and societies adapt to climate change.
Hopefully, in this documentary, you've learned that global warming has happened throughout the Earth's history, that humans are increasing rates of modern global warming, and that humans need to either bring an end to anthropogenic global warming or adapt to it. As you can see, global warming is not some sort of conspiracy theory, nor should there be any reason to dispute whether or not it exists. Global warming does indeed exist, but the problem that humans face today is how to solve this situation that we are in. Whether or not we adapt to or mitigate global warming lies in the hands of the world's next generations.